Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul bin Suparman and I'm from section 6. Okay, today I will present it to you about my topic that I have been chosen, and the topic must be from the engineering material in a mechanical. So I decided to choose isostrain conditions. So, do you know what is the meaning of isostrain conditions? The first thing is you must know the meaning is isostrain means when a composite having a load acting on the composite. Means that the composite have a stress on it. Okay, such an example I'll give to you the diagram of the isostrain conditions. Okay. This diagram shows us an isostrain conditions, which mean by the stress acting on the composites. You know the composites have divided by two layers. The first layers is metric layers. The metric layers and also the fiber layers. This is the layers inside the composites. As we know, the composite divided by two. And then automatically, when the composite divided by two layers, one metric and one for fiber, and then they have a difference for the elasticity modulus for metrics and elastic modulus for the fiber. So this is an equation that I've been used to calculate the EC. EC, which mean by elasticity modulus of composite. The composite, this block is the composites, and this layers is different layers in the composite. Okay, so this equation explains us on the elasticity modulus of matrix EM, and VM is volume of the matrix, while for VF is a volume for fiber, and EF is a elasticity modulus of fiber. Okay, if you see the bottom of this paper, you see this FF and FM. So this formula is to find the force or the load acting on the composite. Each layers, not one, but each layers for the fiber and also for the matrix. So this is the formula that we use. The load acting on the composite and divided by 2, and the load is acting on the fiber and also the matrix. So what's the difference from the isostress and isostrains? You can see the diagram. This is the an isostrain. Okay, the difference is the load acting on the composites, the directions. Okay, you can see the difference. Okay, so that's all for the meanings of the isostrain conditions. So now we go to the explanations of my programming. What's the meaning of programming? Programming is type of program that we created and a coding, and we just insert the value into the coding and we'll get the answer. And this is the simplest way to us to get the find the value. And also in this project, we want to optimize the value of the FF for the load of fiber and FM for the load of matrix. So what we must reduce it, why we must reduce it. Okay, so I will explain to you more about the flowchart and then about the coding that I've been creating.
Okay, let we see the flowchart. My flowchart for the isostrain conditions. First thing is we must do a circle box. That means by start first, and then the second box is user input. The user input is input and output for the user to choose whether he want to go to the EC or FF or FM. EC means by elasticity modulus of the composite. Okay, let we say we choose for the yes. 1 is equal to 1, and yes, we go to find the EC. Okay, the question is what is the meaning of the EC? So we go to the EC, we put in the equation into the box, input and output, and then the next box is we go to the process. Process means we insert the value of EF, VF, EM, and VM. Okay, so we get the answer of EC and we display it. We display an EC, or elasticity modulus of E composites, and then when we display it, we choose whether we want to end this program or we want to loop this program to find the FF and FM. Okay. And then I choose to loop this program. Start for the first at the user input, and then we go through the flow, and I choose no, and I put a false statement. Okay, for this step, we want to find a value of load acting on the matrix layers and load acting on the fiber layers. So this is the equations that involve in this programming, in this coding. So FM is equal to FC multiplied by EMVM over EFVF plus EMVM. So difference with the FF, EFVF over EMVM, and the total we multiply it by FM. So and then we insert the value of EM, VM, EF, and VF. And this questions, the FC or the load acting on the composite are givens, assume are givens. So we need to find the value of FM and FF. Okay, when we get the value of FM and FF, we go through the flow and we display the FM and FF, so we get the answer. And for this path, we should choose whether we want to looping again or we want to end. So I want to end this program by give a false statement, and then we go to no and also end this program. So this program is to find the EC and also the FF and FM. So that's all for the my flowchart function of my flowchart. Thank you. Okay, and then we look for the my coding. I cut and paste the coding into the software. Okay, you see this is float, EMVF, EC, and the other else. Okay, so first I want to find the value of EC, so I put the equation of EC, and then the second equation is for the FF and FM. So this is FF and FM. So this looping coding, looping for the, if you want to choose whether we want to find the EC first or FF and FM first. Okay, so my coding is complete. Then we go to execute, compile, and run this coding. Okay, see this. If you see okay, I want to find for EC first. So EC, I insert the 1, enter. Okay, so we just put down the value of EM. EM is 34000000. Okay, and the unit in gigapascal, I need to change it. The volume is 0.6, and the EF is 69 gigapascal. Okay, the volume is 0.4. Okay, we get the answer. So this is the answer for the EC. And then the bottom is enter 1 to continue and enter 2 to exit. I don't want to exit first and I want to continue first. Okay, so I enter 1. Okay, the programming is looping again for the start. And I choose 2 for the find the FM and FF. Okay, this is the equation that I put on the coding. So just please enter the value of EM. So EM is 3400000000. The VM is 0.6. EF is 69000, and the volume of EF is 0.4. Okay, so this equation we must put the value of FC. We know the FC is force or load acting on the composites. FC is 12500. Okay, so we get the value of FM and FF. Okay, so for this project we want to optimize the value of whether we want to FM or FF. So I want to show you how we optimize it. So I enter for the one, continue. I want to optimize the FF and FM. I choose 2. Okay, I put the values. The volume, we change the volumes for optimize it. Let's say I want to optimize FF or FM. I just change the volume because the volume affected on the load acting on the composites. So 0.8 I choose. So the EF 69. Okay, and the volume is for VF is will remain constant 0.4, and the FC also constant. Okay, we enter. Okay, we see a difference here. Okay, the difference of the force acting or load acting on matrix and load acting on fiber, the difference here. So the difference here we mean by we change the volume in the matrix layers or the fiber layers, and the load acting also will change. Okay, so that's all for my coding. I want to exit the program. I just set to. Okay, so finish my coding. Thank you.